Hi guys, I'm back. What we are doing now is graphing inverse relations. What you've got when you've got an inverse is, this is the original relation, and you have the points 0, 2, 1, 4, 2, 5, 4, 6, and 8, 7. When you are doing the inverse, your x and y will switch. So you're left with 2, 0, 4, 1, let's see, 5, 2, 6, 4, and then 8, 7, 8. There we go. So this thing right here is identical to this, except it is reflected. And in fact, it's reflected across the y equals x, that identity function you had when we were dealing with parent functions. It's reflected across y equals x. And that goes 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. That line right there is what goes through the middle of a relation and its reflection, or a function and its reflection. They have made this here the continuous domain because we've joined all the points, and they flip. Your domain here is between 0 and 8. Okay. Your range is between 2 and 7. And they flip. The range goes to the domain, and the domain goes to the range. That's what makes an inverse. Excuse me. Writing and graphing inverse functions. All right, so if you are going to do this, and you just have an equation, you don't have the points, you could get the points, just look at them and do the opposite, or you can get an equation. And what you would do is, the first thing first is switch x and y, and then you have to solve for y. That means get y by itself. Now, some of you did not do this on the one we had before. Make sure you pay attention right now. When you're getting y by itself, you are getting everything over with the x. So the first thing you'll have to do is subtract 6. So you'll have x minus 6 equals 3y. Still need to get y by itself, so you will divide through everything by 3. And that will be y equals x minus 6 over 3, or what they've got down here, 1/3 x minus 2. So you have minus 2 right here, just like we did on Desmos, up 1 over 3. Okay, and I went down 1 and over 3 to keep it in line. That would make it. Okay? Make sure you can do that. If the function is exponential, which is where we are now, we're going to need to define another term. X equals 2 to the y when I switch these around. Only you're pretty much stuck the same way you were before. So what we're going to do is drop logs on it. You're going to bring in a logarithm. And then you bring y down in front of that, y log 2. So y equals log of x over log of 2. That solves it. And so y equals, this right here, you'd have 2 to the y equals x. Okay? The inverse of that is log base 2 of x equals y. Because y equals b to the x and y equals log base b to the x are inverse functions, their compositions map number a to itself. In other words, if you've got b log base b of a, that'll equal a, and log base b of b to the a equals a. So this just will cancel out, and you'll leave a, and that will cancel out and leave a. That's one of the properties that comes up next. Right? A logarithm is an exponent to which a specific base has been raised to obtain a specific value. So b to the x equals a. To write it in logarithmic form, b to the x equals a. Just about every teacher you know will do b to the x equals a. Okay? You can switch back and forth between the two forms. Which is a favorite? 2 to the 6th equals 64. Log base 2 to the 6th equals 64. A lot of people will write exactly the way I just showed you. 4 to the 1st equals 4. Log base 4 up to the 1st equals 4. And that's perfectly fine. But you want to make sure that you can go between exponential form and logarithmic form. Okay, so log base 2 of x equals 4. So 2 to the 4 equals x. And that's all I'd have to write. 2 to the 4 equals x. That is 2 times 2, 4 times. So 2 times 2 is 4. And 2 times 2 is 4. 4 times 4 would be 16. 3 to the x equals 9. So you know 3 squared equals 9. So x equals 2. X cubed equals 27. So you could break down 27 into 9 times 3 and then 3 times 3. So x cubed equals 3 cubed. And that makes x equals 3. It works just the same on the bases if the exponents are the same as it does when you've got the bases the same and you're looking at exponents. That's also equal. So either way you want to do it, it's correct. This one, 16 to the 3/4 equals 8. All right. You're just rewriting it over. What that means is the 4th root of 16 cubed. And we know what the 4th root of 16 is because we just did 2 to the 4th. So the 4th root of 16 is 2. And 2 cubed is 2 times 2 times 2, which is 8. So a little review on that. Solving equations with the same bases. Well, this is just about breaking them down so that we've got the same base, and then we will make the exponents equal, just like we did here. So if they got the same base, your exponents better be equal. So right here you've got 16 to the 3x, and we know that is 2 to the 4th, because we just did it. We know that 8 is 2 cubed, because we just did it. So 2 to the 12x equals 2 cubed. So if you want to solve for x, then 12x equals 3. Divide by 12. And x equals 1/4. All right. And the last one here. Break down 27, 9 times 3. Well, we just did that one on last page too. So that is 3 cubed to the 5x. And 81 right there is 9 times 9. And you already know that 9 breaks down into 3 times 3. So this is 3 to the 4th. So 3 to the 15x equals 3 to the 4th. And your equation then is 15x equals 4. Divide by 15. And x equals 4/15. Okay. So that is all we've got. And let me know if you've got any questions.